Hi, this is supplementary math lesson for Algebra 2, 77B in your textbooks. I'll be doing homework problem B and example 77.3 from your textbooks, page 309. If you want to follow along in your textbooks, you can do that. Pause the video now, turn to page 309 in your textbooks. So this is a continuation of yesterday's lesson. How do we handle solving for equations if our normal factoring methods don't work? How do we solve equations that have weird powers to them? You know, like we did yesterday, a power to the third. How do we handle if we have weird radicals, weird square root type of functions? And today's equation, today's lesson, how do we handle equations when there's more than one radical expression in the equation? Excuse me. Well, the drill is the same as yesterday. We isolate the radical symbol on one side and we raise it, we perform the operation to get rid of that symbol. Now in this case we have two of them. So which one do we isolate? Typically you will isolate the most complex one first. So this only has a square root of s. This has an s minus, so we're gonna isolate that one. Okay, the square root of s minus 16 on one side. We're gonna take everything else to the other side. It's gonna be 4. We're gonna subtract the square root of s from that side and the other side. Okay, then we perform the operation to get rid of that radical symbol. Okay, it's a square root, so we're going to square that term, and we must do so to the other side as well. Now we said when we raise both sides of an equation to a power, we make a mental thing. We've got to check our answer. I'm going to put a little checkbox there to remind me to check the answer. That is a must when you raise powers, each side to a power. Okay, so what do we get here? Well, that gets rid of our radical symbol, leaves us just with the expression under the root symbol, s minus 16. Okay, here, what does this give us? Well, we have to multiply that out. So if I get rid of my squared symbol and think of it as multiplying this thing by itself twice, okay, I go ahead and multiply it out. I get a 16 minus a 4 square root of s. Then do this distributive, minus a 4 square root of s. And a minus square root of s times a minus square root of s gives me a positive s. Okay? So then what do I notice? As I said yesterday, if we have similar terms on either side, they cancel out. If I look at it, if I subtract an s here, I would subtract an s there and get rid of it. So I'm going to go ahead and cross that out. Those s's cancel out on either side. Okay? So what do I have? I have a minus 16 equals a 16. These two are like terms. I combine them as 8 square root of s. Okay? And that's what I have. Okay, so then what do I have here? I have another equation with a radical symbol in it. I apply the same process that I did here. So I'm actually going to be doing that thing twice. What am I going to do? I'm going to isolate, okay, the square root symbol equation on the term I want to eliminate. I want to eliminate the square root function there. Okay, I'm going to isolate that square root function. This time, since it's on the right side, I'm just going to leave it on the right side. It doesn't matter what side you isolate it on. Okay, so let's take the 16 over here by subtracting. This becomes a minus 32 over here equals a minus 8 square root of s. I divide out that minus 8. Okay, what does it leave me leaves me, and I'm going to running out of chalkboard here, I'm going to go up here. That leaves me a 4 equals the square root of s. Okay, now I've isolated that square root term. I'm going to square it and square it on both sides. That gives me 16 equals s. Okay, so I've squared that again on both sides I would make a mental note. Okay, I've got to check my answer. Put a box, a check mark with a box. Well, I've already made that mental note. Now I'm doubly sure I have to check my answer. Okay, this is my possible answer. Let's go ahead and plug it in. Let's see if I can sneak that in here at the bottom. I'm going to plug it into my original one. It's going to be the square root of 16 minus 16 plus the square root of 16 equals 4. Okay? I'm sorry about my messy. It's kind of hard to write on the chalkboard sometimes. So I get a 16 minus 16 under the radical symbol, which is 0. The square root of 0 is 0. That term there is nothing there. It's 0. So I get a square root of 16 equals 4. What is the square root of 16? Okay? It's 4. 4 equals 4. It checks out. So my answer is S equals 16 in that case. Okay, it checks out. We must do that check. Okay, let's go to that example 77.3 on page 309 in your textbooks. Look at them here. They look like very, very similar situations equation-wise. Okay, the drill is the same. Let's isolate the most complicated radical expression first. The S minus 8 under the radical symbol. Move everything else to the other side. I get a 2 minus square root of S. Okay. Then I'm going to square that side to get rid of the radical symbol. Okay. Then I make a mental note. Since I'm doing that, I got to check my answer. Okay. That gets rid of my radical symbol. Oops. S minus 8. Okay. That gives me here, well, I have to multiply it out. Okay, I get a 2 times a 2 is a 4. Okay, I'll get a 2 times a minus square root of S will be a minus 2 square root of S. Okay, but when I do it here again, that's when I did this. 2 times 2 is 4. 2 times minus square root of S is minus 2 square root of S. I do this division, I get another minus 2 square root of S. Okay, they combine into a minus 4 square root of S, and then I multiply my last two terms. A minus square root of S times a minus square root of S gives me a positive S. So what I did, I just did a shortcut. Instead of multiplying out, I get all four terms here. I noticed that the two middle terms combined, I just combined them here in one step. So I hope that didn't confuse you when I multiplied it out, because look at it, it's the same form. It's a number minus a square root, number minus a square root times itself. Okay, it's the same process. Okay, so what does that give me? Let's isolate this square root of S symbol now to get rid of it. Okay, so I'm going to leave it here on the right side. Let's take everything else on the left side. If I take the S over, the S's cancel out. Okay, if I take this number 4 over, I subtract 4, it becomes minus 12 equals minus 4 square root of S. Look at like it's tracking along the same thing, the same way that our other problem did. I ended up with a minus 32 equals a minus 8 square root of S. Here I have a minus 12 equals minus 4 square root of S. Okay, I divide out that minus 4. Okay, I get 3 equals my square root of S. Now I have that term isolated. I can get rid of it by applying the proper operation, which will be squaring both sides. I square both sides. I make a mental note. I must check my answer. Okay, and what do I get? 3 squared is 9, and I get S. So there's my possible answer. S equals 9. Now I doubly had to check it, just like our last problem. Let's plug it in. I get a square root of 9 minus 8 plus the square root of S, which is, 9, equals 2. Okay, what do I get? I get a 9 minus 8 is 1. the square root of 1 is 1. I'm going to go up here. I see I'm running out of chalkboard. So I get a 1. I get a square root of 9 is 3. A plus 3 equals 2. Okay, what does it give me? It gives me a 4 equals 2. Does 4 equal 2? No, it doesn't work out. Wow, it's amazing. These are almost they're the exact same format in the problems. It's just the numbers are different, slightly different. And actually, they're not different by a real whole lot. The numbers are half. The numbers in this one are half of what there are over there. Okay, and yet when we're going around, it's tracking the same way every step, and we get numbers for the end product, and yet this one does not work out, and that one did. Okay, that's kind of puzzling, isn't it? Well, that's what happens when you square both sides, or you raise both sides of an equation to a power. It's possible we get solutions that are bogus, that do not work, that do not compute, like this, 4 equals 2. So what is the answer there? The answer is no solution. Okay, doesn't work out. So that is the answer for that example problem. I just picked those two problems because they're very, very, very similar, and yet one has a solution and one doesn't. So I hope that helps with your lesson today. I'm looking at the syllabus. We have you have a review problem set Thursday, so we won't have a video, and then nothing for Friday. So hope you enjoy your weekend. Next week, the last 2 weeks of the course, we're going to be into vectors. That's all we're going to do is lessons on vectors. So we won't be introducing any other new topics. Besides that, we'll kind of park on that and take us through the end of the year. So hope that helps for today's lessons. Shoot an email or a text message with any questions. Bye for now.